In Precalculus section 2.1, we're dealing with power and radical functions. So a power function is f of x equals ax to the power of n. So there's a coefficient a, and this is x to the power of n. This is a monomial, so it's just a term independently. And next section we'll deal with when you start adding and subtracting a collection of these functions. So here's an example. Negative 3/4 x to the negative fifth. So your a is negative 3/4 and your n is negative 5. And this is what the graph looks like. Okay. It's going to ask you for questions to identify, for example, domain, range, intercepts, and behavior, continuity, and increasing, if it's increasing or decreasing. So what you're doing is you're reading the graph, and they're asking you for information to read the graphs. You've dealt with domain or range, but I haven't done any explanations in the videos, and so now I'm going to do it. Domain is the value of x, okay, where the x right here is limited and where it is valid. So for example, here the domain, the x values are valid here, but then here there is no x values. These x values are negative, and then this x value is positive. Now, the thing is that at this point right here, it gets close, but it never touches. So then we have what is called an asymptote. Okay, this is where the equation is not defined. And for the range, which is the values of y, it's the same thing. At y here, it gets close, but it never touches this line. Actually, no, it does touch. It goes straight on it. Sorry, it's really hard to see, but it does in fact touch. So then therefore, y is valid everywhere. The intercepts is where it crosses the x and y axis. The end behavior, so the limit is to negative. So as it goes to the negative, what happens? That's how it's written. Limit x goes to the negative infinity. So as it goes to infinity negative, how does it look? And then for this one is how does it look to the right? So the end behaviors, the far left and the far right. And the continuity is anywhere it disconnects. So in this case, we found that x is not valid, the domain is not valid at x equals 0, because it never actually touches on 0. It gets close to it, but it never touches it. And then it's increasing or decreasing. It would be increasing here, because as we go here, it gets bigger, 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 and then it shoots up. And then as we get from here to here, it decreases. So we're going to write that all down. So pause and write what each one means. We're dealing with domain and range. So we discussed here, domain is the x. And we know that with the x's here, where's my x right here? Sorry, I cut off. This is my x. So we know what with the x axis here, wherever my x is, it never completely reaches 0, right? So the domain from here to here goes from negative infinity to 0. Then from here, it goes from, and I include 0, it excludes 0, because it never actually touches 0. Right, so we'll do this. Because if it did include it, then I would do this would be the motion if it included 0, and then this would be the symbol for it not including 0. And then a union, that means and, because if it was the other way, it would be a disconnect. The domain would go from here, it goes from 0 to positive infinity. But it never actually hits 0. That's what that's saying. And the range is the same. Well, actually the range, because it does hit 0, unlike the x, will then go from negative infinity to infinity. The intercepts, because it doesn't reach your intercept here, for y-intercept, it hits the y-intercept here and here, so these go by 2's, so this would be 1. So 1 and -1, so the y-intercept would be 1 and -1. And then for the x-intercept here, because it never actually hits the x-axis, it just gets close to it, then the x-intercept is none. Now, the end behavior, each of them, the goal is to approach 0. Approach 0. I'm sorry, it's the other way around. The x-axis, the x-intercept hits a 1 and -1. Right here. But the y-intercept, it never hits it because it gets so close to there. That might be a little confusing. I'll clarify that in class. The end behavior, as it approaches infinity, so from -infinity, how did I write it? X goes to -infinity. So as it goes this way, its goal, but it never actually reaches it, is f of x equals 0. It's approaching 0. This one, the limit of the other side, x to infinity, is f of x equals 0. The continuity is that x here, there's a disconnect. That means we don't reach it at x equals 0. So when x equals 0, there's no function. It approaches it, but it never actually hits it. And increasing and decreasing. I think when we did the other board, I said it was increasing here and decreasing, but as you can see, they're both actually increasing. So it increases from -infinity to 0, and then from 0 to -infinity. That's us reading that chart. So, I know that might have been a little confusing. It was, I'm not sure if I explained it correctly, but I'll go over it in class. So you can go ahead and pause and write this down. I have one more board for you. This one deals with extraneous solutions, and we kind of touched base on it before, but extraneous solutions deals with solutions that we might get at the end as an answer, but then when we plug it in, it actually doesn't give us an answer. So if it states the extraneous solution, you can't just stop at solving it. You have to then plug it in to see if it works. So the first step is just to solve it. So let's solve it. We have 2x. The first thing is to isolate this square root. So I'm going to plus 3 on both sides. So we have 2x plus 3 equals square root of 28x plus 29. And I'm going to square both sides. And this would square 2x squared would be 2x plus 3 times 2x plus 3, which would be 2x plus 3, and then plus 3, 2x plus 3, giving me 4x squared plus 6x plus 6x plus 9, which is 4x squared plus 12x plus 9. Hopefully you can see that. Yes. Okay, so this becomes 4x squared plus 12x plus 9. And these cancel out, leaving me with 28x plus 29. Then I'm going to, because I have that squared, I'm going to move everything to the other side, equals 0, so that I can solve my quadratic equation. So I'm going to minus 29 to both sides, and I'm going to minus 28x to both sides, which then gives me 4x squared minus 16x, and then minus 20. Yes. Now they all have 4 in common, so I'm going to take out a 4, and we're going to do x squared minus 4x minus 20. So then this becomes 2 parentheses. 2 numbers when multiplied together gives me negative. All right, so I made a mistake. I took out a 4 here, but I didn't take a 4 here, which is 5. So 2 numbers when multiplied together gets me negative 5, and when added together gets me negative 4, which means this is positive 1. No, negative 1, 5, positive 1. Ha, got it. So from here, I'm going to erase this. This video is long enough, so we can do that one in class later. I just want you to see this. So we're going to move this here, and we're going to solve it. So 4x minus 5, x plus 1 equals 0. So then I do x minus 5 equals 0. I divide both sides by 4. So then I have x minus, this cancels out. I have x minus 5, x plus 1 equals 0. So x minus 5 equals 0, and x plus 1 equals 0. So this will give me x equals 5 and x equals negative 1. Oh, that was a long problem. Okay, so that is what you're used to, but then the extraneous solution comes, and that means one of these might not work even if I plug it in. So now I'm going to have to plug it in. 2 times 5 equals square root of 28, 5 plus 29 minus 3. So this gives me 10 equals second square root 28 times 5 plus 29. Nope, that's not right. Nope, sorry. 13. 13 minus 3, so 10 equals 10. And then this is then a solution. So now I have to do the same thing with negative 1. 2 times negative 1 equals square root of 28 times negative 1 plus 29 minus 3. 2 times negative 1 is negative 2 equals 28 times negative 1, square root of negative 28 plus 29 minus 3 gives me negative 2 equals 1 minus 3. So negative 2 equals negative 2. So this also is an answer. But, unfortunately, I think the other one had just one answer. But if you get my drift, if these don't end up the same and these don't end, one of these could be an extraneous solution. So make sure that you check them to make sure they're both the answer. In this case it is. So our answer is 8x equals 5 and x equals negative 1. So pause this, write it down, try guided practice numbers 5A and 6B, and I will see you in class.